my dearest of the dearest students, let's start. I was telling all of you, all four of you, that we have actually lost one full week. And actually, let me remind what we were learning, long back, actually, I should say. Long back, I started with a topic called object-oriented programming in Python. And I was teaching you about class and object. How to create a class, how to declare objects, and how to call methods of those objects. I was telling you. Now, under OPM, we have to learn a lot of other things, like concepts like inheritance and polymorphism. Then there is something called overloading. Okay. Then containership is one very, very interesting concept. Containership in OPM. So many concepts are there. Okay. So all these things are pending in OPM. What else is pending to be taught is files. How do you deal with files in Python? Like, you want to open a file, you want to read something from the file or write something in the file. All these things are pending. But trust me, I'll be coming back to all this time and again. I don't want to disappoint all of you, but actually, what we should do now is we should put hands to something called machine learning. Okay. And simultaneously, we will keep learning OPM and files. As far as my knowledge goes, you have tasted Python enough now. You know what is list, you know what is tuple, functions you have learned. Okay. Various concepts in the functions you have learned, types of parameters in the function you have learned. And on one fine day, I also taught exception handling to you. Although very few students were present in that class, but exception handling, you can get the recording of the exception handling on YouTube, and you can just watch that video if you're not done so. Okay. So what I have planned for the day is that let's think of something called data analysis. Data analysis in Python. You can say that this is the first step in the machine learning. Now, my method of telling you this subject is something different. Usually, any teacher would start with the definition of machine learning, and then what data you are analyzing and why you are analyzing the data. Such will be the methodology. But my method is something different. I will first practically tell you what we are doing. Okay. And then gradually I will come to various definitions which are related to our subject, and you will ultimately know, okay, that's machine learning, what we are going to learn throughout this course. Okay. So our point of discussion is data analysis in Python. Now, what kind of data are we talking about? Maybe it is data about 10,000 cancer patients. Now, some of these patients didn't have cancer, some had cancer. Okay, so their readings were taken. Various patients reported to various hospitals, their readings were taken, and after that, it was diagnosed that the person does not have cancer, but few people had cancer. So how would this data be looking like? There will be some reading one. I am not an expert. So there will be some reading, maybe hemoglobin, maybe blood pressure, whatever. Some readings were taken. Let's call this as R1, R2, R3, R4, R5, R6, R7, R8. 8 readings were taken. 8 various tests were done. And then first patient came in, readings were taken, all the tests were done. And then whether that person has cancer or not was found. And let's say if the person didn't have cancer, 0 was stored here. Similarly, second patient came in and these same readings were taken. And then it was found that this person has cancer, and so on. Now, please try to understand whether the person has cancer or not was found by the doctor. We didn't use any machine learning for doing this. Literally, doctor using his or her skills had found whether the person has cancer or not. Obviously, in the domain of cancer patients, doctor is the master, obviously. So all this data, is available to us. Maybe many hospitals have recorded this data over past many years. Maybe past 10 years data we are having, various readings and whether the patient has cancer or not. And we have some 50,000 such rows, maybe 50,000 rows. That means 50,000 patients over last 10 years had undergone this test, and various hospitals have helped us by recording this data. But nowhere in this recording, machine learning was used. This was all master's job. These are all predictions. These are all readings or diagnosis done by experts. Imagine we have such a data. I mean, what can we do with this data? What we can do now, if I hope you are understanding, these are various readings of medical diagnosis. As I said, blood pressure, maybe hemoglobin, maybe cholesterol, and so on. I don't know what exactly is tested in cancer. Maybe one column might be there. Is the patient a smoker? Maybe. Yes or no. So 0 for non-smoker, 1 for smoker, maybe. Or hypertension readings, and great work has been done. You see, what we can do is we can write a program, literally a Python program we can write, which can predict whether patient has cancer or not, if some new data is given. New data, by new data, what I mean is that we have 50,000 rows, right? Let's say 50,001 patient comes, okay, and readings are taken for that patient, and now doctor will not intervene. We won't call any doctor, but our program will see these readings, will check these readings, and using this past knowledge, which experts have told, our program will tell whether that patient has cancer or not. This prediction will be done by our Python program. Still, the readings have to be taken. All these readings will be taken by hospital staff, and then our program, our software will tell whether the patient has cancer or not. So now, what the job of that expert, the doctor, has been done by our program, isn't it? But how will our program predict this? Only if the past data, huge set of data is given. And what it will do, it will learn. That's the word. My Python program will learn from this data that if these are the readings, high chances that patient does not have cancer. If such are the readings, high chances that patient has cancer, and so on. And then it will keep learning. And then suppose on one fine day, some new readings are given. This is a new patient. Some new readings are given. Then it has our Python program has studied the past data, and it knows in which situation the patient does not have cancer, in which situation patient has cancer. So our Python program can predict 0 that the patient does not have cancer. That is machine learning. Machine learning, in one word, is learning from the data, making predictions from the data. That's a very partial definition I have given about machine learning. Machine learning is much more than that. But in the easiest nutshell, I can tell you that machine learning is making predictions from the given data. And notice, to write this program, you don't have to be cancer expert. You have to be programmer. You do not know ABC. You do not know ABC about this process, but doctor has already helped you in which situation patient does not have cancer, in which situation patient has cancer, and so on. And then you build a solid algorithm or a program which learns from this data and then makes predictions for every new patient. That is what is machine learning. Okay. But assume that as a programmer, you are given this task. And on one fine day in early morning, you get up and you get this good news that you have got this work to be done, and you suddenly start wondering, I don't know anything about this, about these readings and all this entire process I don't know. What you can least do is you can actually talk to an expert or as many experts as possible, and in layman's language you can ask them that what is this reading all about, and so on, and try to gather as much as possible from the expert. Like, you might ask the doctor that how did you predict that this patient has cancer? Look, predicting that patient has cancer is very risky. That's very shocking for the patient. How did you do that? Doctor may say that reading 1, reading 4, and reading 7 cross a particular range. It is crossing a safe range. So you know now that there is some range associated with it. Maybe 7.0 to 9.0 is a safe range, and patient had R1 reading as maybe beyond that. Same goes with R4 and R7. Something like that, some domain knowledge you gather from the expert, and then you get greater insight about the data. I hope you are understanding. Now, as another example, I'll take you to a Google page now. Sorry, Wikipedia. Let's say iris data set. Now, this is a very famous data set, which is used by almost all the teachers while teaching machine learning. Initially we use this. Now, what biologists did is they collected data about various flowers which belong to iris family. Iris is like a family of flowers, like gulab or rose. Rose is a family, and there are many types of roses. Like that, iris is a family, and in this family there are 3 types of iris flowers, which are iris setosa, iris virginica, and iris versicolor. Please don't get mesmerized on hearing these words. These are European names of the flowers, or maybe biological names, what you say, the nomenclature, isn't it? And they have shown with some examples over here. This is how, just check, this is how iris setosa looks like. This is how versicolor looks like, and this is how virginica looks like. You can see that all of them look quite similar, with a few differences. Now, how this difference was found out by botanists was they used the following parameters. You see, these large size objects here on the flower are called petals, and the small size extensions are called sepals. So for each flower, they collected petal length, this petal length, and petal width. They kept collecting such data, and this is sepal length and sepal width. So they collected 4 things: petal length, PL, let's call it as petal width, okay, PW, let's call it as sepal length, okay, and sepal width. I mean, they just started collecting as many flowers of all 3 family, all 3 types of flowers, and they recorded these readings. Okay, and they already knew which type of flower it is. Come on, they are the experts. So then they wrote, this is iris setosa. Then for these values, petal length, petal width, sepal width, this is iris versicolor. So the last column, last column, just as in this case, was whether the patient has cancer or not. Recall, last column was this. Here the last column is which type of flower it is, whether iris setosa, iris versicolor, iris virginica. We call such columns as output columns. Even in the case of cancer, the last column was output, whether the patient has cancer or not. Many authors call this a label also. label, output label, you can say, correct? The result of all these readings, which type of flower it is. So can you then say that 4 readings were taken? Just as in the case of cancer data set, 8 readings were taken. Here 4 readings were taken of various flowers, and we recorded, or rather experts recorded, which type of flower it is. Okay, just see, we have got sample data, I think, over here. Where is it? Yeah, this is iris data. Wait a minute. I'll just show this data to you. This is how the data looks like. Just see, this is just the number given to the row 1, 2, 3, and so on. And botanist collected data of 150 various flowers. Check 1 to 150. And you see sepal length, sepal width, petal length, petal width of one particular flower was taken, and they already knew that this is Iris setosa. They are experts, but they recorded this data, and they said which type of flower it is. See, many setosa flowers you can see, then some versicolor flowers, then virginica. Three types of flowers are there. 150 rows they recorded. Now, what can you do with this data? What can you do? Now, suddenly, if some new flower belonging, new flower, which belongs, we know that this belongs to Iris family. To Iris family. Huh? Some new flower which belongs to Iris family, we know, but we don't know which type of flower it is. Iris setosa, Iris versicolor, or Iris virginica. But we take readings of this. We take sepal length, sepal width, petal length, petal width. Let's say sepal length is 4.8, sepal width is 3.2, petal length, let's say, is 1.6, and petal width, let's say, is 0.3. These are the readings we got. But note, we don't have expert with us now. We don't have that botanist with us. But our Python program should use these readings and then tell which type of flower is this. But how will our program come to know which type of flower is this? By learning. By learning from this data which is given, that in such situations it is setosa, or in some other situations, some other type of readings given, it is versicolor, and in some other kind of situations it is virginica. That is machine learning, making predictions on the new data by using the past data. Okay, I hope you have seen number of times an ad on the YouTube, which usually always comes before playing a video. You know, that person tells I like that. I mean, the way that person tells. I forgot the name. He is actually an entrepreneur of some company. You know what he says? People often ask me, what can you do with data? Can you have some insight of data? Like that he starts. It's a very good ad, actually. What can you do with data? So wonderful. Actually, if some label data is given like this, and some hard work has been done by the domain experts, then we as Python programmers can do much with this data. Okay. Now you can just think of endless examples. Maybe whether earthquake will occur or not. So last column is earthquake. 0 for earthquake will not occur, 1 for it will occur. And these columns will be some readings. Some land readings, tremors, pressure, temperature, whatever it might be. The wind flow, all the parameters will decide whether there will be earthquake or not. And this will be recorded. This data will be recorded by environmentalists or experts. And then, given the new data, our Python program will tell whether earthquake will occur or not. Great. Well, this type of machine learning, you know, that is, check whether the patient has cancer or not, check which type of flower it is, check whether earthquake will occur or not, is called as classification problem. This is called classification. Because in the case of cancer, we have two classes, 0 or 1. Either patient belongs to this class or patient belongs to this class. Ultimately, our program, Python program, should output 0 or 1. 0 is very, very good news. Patient does not have cancer. So what prediction, what kind of prediction our program is doing? Our program is actually telling which class does the patient belong to. Flower, in the case of flower, we have three classes. First is setosa, next is versicolor, and third is virginica. Three classes. But ultimately, our program will output one of those three classes. In the case of earthquake, again, 0, no earthquake, 1, high risk or high chances that earthquake might occur. So this is again a classification problem. Initially, in our course, we will be concentrating only on the classification problem. Okay, we'll learn only classification. But the other type of machine learning solutions is regression. I'm not even discussing it right now. Okay, but besides classification, we have something called regression. Okay, and then there are many more terms, like we have supervised learning, then we have unsupervised learning, lot of other things. But enough, if you have understood what the data is, what we are trying to do, what prediction we are trying to make, and why these kind of predictions are called classification problems. Enough at this point of time. Okay, well, now what is our plan then? What we will do next is, what we will do now is you know, is that we will take up a problem of iris flowers, and this problem will go on for a few weeks. We will take marginally, we will take other problems also. Okay, but this problem of iris data set will go on for a few weeks along with other problems. So what I will do is I'll start a new notebook. By the way, where can you get this iris data set? You know, to work with it, you should first of all have this data set. So what you can do is you can just Google out again. You can Google out download iris data set. Iris data set CSV. I'll tell you what CSV is, but you can see first suggestion you get is iris species Kaggle. Kaggle.com is a very good website where a lot of competitions are held and lot of data sets you will get. See that it takes you to the page iris species, and it is already on the tab data. Okay, and you can see down below here iris.csv. This is the file. You can just click on download and this file gets downloaded. So I have already downloaded this file, iris.csv. Okay, it will be interesting to see how this file looks like. So I'll go to my my computer, and just give me some time. I'll go to computer. I'll open this file before we work on Python. Here we are. Yeah, this is the file, iris.csv. I will just right click it and say open with Microsoft Excel. You can open CSV file in Microsoft Excel. It will take a bit of time to open Excel on my machine, but you will very well see that whatever we were seeing, sepal length, petal width, and petal length, and then the output column, which type of species it is, will be there in this iris.csv. Meanwhile, it is opening. Meanwhile, I'll tell you how exactly this file is made. I'll tell you. This is CSV file, comma, separated value file. Now, how this is made? You just check. Suppose you are recording sepal length, say 1.5, then comma is put. Literally comma is typed. Please try to understand. While creating this file, we say 1.5 comma, maybe next is sepal width, it is 1.9 comma, next is petal length, it is 4.8 comma, next is petal width, let's say it is 2.6. This ends one line because this is one flower, and then comma, do you say it is iris setosa, like this, iris setosa. So 5 columns are there. Then there is a header put sepal length, sepal width, petal length, and petal width. And this is species, which type of flower it is. Then next row, this is second flower, 1.8, 1.95, 1.6, 4.7, comma separated, and then 2.8. And this is also iris setosa, it says. And you will find 150 such rows, because botanist has recorded 150 such flowers. But this is such a simple file. You see, it's just comma separated file, and you can create this in Notepad also. You don't need any extraordinary RDBMS to create such files, or simple Excel. You can create this file in Excel. Let's see how it looks like in Excel. You can open any comma separated file in Excel. This is how it looks like. Just check. This is just an ID column. This is number given to the row, and sepal length, sepal width, petal length, petal width, and species. And we have 150 such flowers data. Okay, so we already have this file. But the point is, we don't want to work in Excel, although Excel is also very good for data analysis. Let me tell you, machine learning or data analysis can be done very well in Excel also. Okay, but we are not going to use it. We are going to use Python for analyzing or working on this data. But we already have this data. That's what I wanted to prove. Okay, so I'm closing this. You all know now how this CSV file looks like, and from where can you get it? You can just Google out download iris, and then once you say download iris, you can go to kaggle.com, the first suggestion, and you can see iris file here, and just click on download, and the file gets downloaded. Okay, fine. So I have already opened one new Jupyter notebook. Okay, now what we will do is, that iris.csv, you know, that file, we will open in Python. For doing that, we use a library. We use a library called Pandas. Now you all know that this is a module now. We have learned this import statement. What does import do? Import imports a module. And what is module, by the way? Module is Python file. Remember the definition of module. Any Python file having extension .py is a module. And what does module contain? Functions, various functions. So we can import this pandas as PD. Recall, PD is just an alias given, short name, so that we don't have to write pandas everywhere. We can write PD. Now let's open our in Python. Which file? Iris. So I'll write some variable name df is equal to pd dot read csv, and then in quotation I will give the name of the file, iris csv. Check. Do you understand? Read csv is a function in pandas module. In this module, there are a lot of functions. One such function is read CSV. And what this read CSV wants is just the name of the file. That's all, which you are downloaded. Now, what this function does, it opens this iris.csv and loads that iris.csv in df. Any name can be given here, X, Y, Z, any name. But I usually give df because what it does, it opens the file and it creates a data frame. What it does, it opens this file. This is the file, okay, and we have written df is equal to pd, which is pandas dot read underscore csv iris dot csv. Correct? What it does, this is iris dot csv. It opens this entire file and loads it in df. Df is a variable, and this df is a data frame. This is a data frame. Just a word. You didn't like it, forget it. Just a word. Data frame. Okay, why? Because now this data frame looks like a nice matrix where there will be id, sepal length, sepal width, petal width, species. Then nice rows will be there and columns will be there, and then values under each column, and these values will be loaded, and you can happily watch this without any trouble. It looks like Excel sheet. But one more column will be added. You will see this. One more column. This will be numbered as 0, then 1, then 2. Additional row number has been added in the data frame. Additional row number, it will always add. And the very first row shown, this is the first row. These are headings, isn't it? I'm not counting this. These are headings, but the very first row is numbered as 0, then 1. So the last row will be numbered as 149. Recall, there were 150 flowers. This entire thing, you can say, oh, sir, this is a matrix. I agree. You call it as a matrix. It contains rows and columns, and every column has a name. Those who have learned DBMS might say, sir, this looks like a table, an SQL table. I mean, I agree, no problem, but it's actually a data frame. Okay, it's a data frame. Okay, let's see. Let's go back and let's try to execute this. So is this running? Let's see. It's still running. You can see the star mark over here, and the file is opened. How do you confirm it? Just give df, and it will print whatever is there in df. Df is the data frame, you recall. And good Lord, look at that. This is your data frame. I told you that Python will add one more column, the row number, and the last row number you see is 149. So that proves there are 150 rows, and these all columns were there in our CSV file. You recall? ID column was there, sepal length centimeter, petal length centimeter. So all these readings are in centimeters, not in inches. Petal length centimeter, and finally species. Because there are so many rows, you know, it is not showing all the rows. After fourth row, it has shown some dashes, and then last 5 rows. So first 5 rows and last 5 rows it shows, because it's a huge output. 150 rows is a lot to show. So this is the first lesson. I mean, any machine learning engineer, I mean, first collects the data. See, first thing is you have to collect the data. So if you don't have data, what analysis will you do? What prediction will you do? And there should be some source from where you will get the data. So we downloaded the data first. Second step is to open that file which contains the data and load it in data frame. Let's try doing print type df. You know this command, isn't it? Type of this variable. What is the type? Let's see. Oh, good Lord, it is data frame. That means there is a class called data frame, and this df is an object. This df is an object of that class. Like, if you know, if I say x is 10, and if I say print type x, you know it is going to print int, because x is storing a value of type int. Then you say x is an object of class int. I hope you recall this. So here df is an object of type data frame. That's why I insist to remember this word. And data frame very well looks like a table or a matrix. We have seen the output there. So I hope you will not forget this first lesson. Second lesson, let this be as it is. Okay. The second lesson is, let's say out of curiosity, we want to know which columns are there in that df data frame. Of course, we can give df and run, and we will know which columns are there. These columns are there. But this is also printing a lot of data. What if we want to print only the columns? Which columns are there? So you can ask for which columns are there by writing df.columns. Now have a look at this. Take your own time. This is the object I said. Df is the object, and then we are writing a dot. Whenever we write object name and dot name, dot, then we are using some resource of this data frame class. Okay. Then you see what we are asking is df, you are the data frame. Tell me how many columns you have. So when I run this, this will nicely print all the columns. And just check few more things. All the columns have been printed in square bracket. Just check this. List of columns are printed in the square bracket. What do you say? What is this? What is this exactly? They are printed in the square bracket. This is list. Hello, this is list. So when you write df.columns, you get list of columns. Agreed? And you also see all the column names have been written in quotations. All the column names are inside the quotation. Okay. A few things to be seen. Okay. That's the way how you can instantly know which columns are there in your data frame. Now, what if you want to know how many rows and columns are there? You know there are 150 rows, right? Yeah, 150 rows are there. And how many columns are there? Sepal length, sepal width, petal width, species, 5 columns. Then wait, one more ID column is there. So 6 columns are there. But if you want to know how many rows and columns are there in df, so you say df, tell me what shape you have. df.shape. So this is going to print 150,6. Look at this. This has got printed in round bracket. Round bracket. This is a tuple. Okay. And it's saying that your df, the data frame, is having 150 rows and 6 columns. And it is evident from here. If you count these columns, these are 6 columns, including species and ID. Now come back to the command df. You know, it displays all rows except, I mean, because it is such a big data frame, it is not showing all, but it's showing first 5 and last 5 rows. Okay, there is one alternative. You can ask for df.head. df.head. You wrote df.columns, but you didn't give bracket here. Just check. You wrote df.shape here, but you didn't give bracket here. Just check. But you gave df.head bracket. What do you say? What do you say? This head is a function which is defined in df. And who is df? df is data frame class, object of this class. So in this class, there is a function called head, but shape is not a function, or columns is not a function. Please try to understand. Please try to understand. Shape or columns are called attributes. Attributes of data frame. These are attributes. Whereas head or tail is a function, are functions. Functions or operations that we can do. Operations of data frame. I hope you know what do you mean by attributes. Attributes are properties. Like if I ask you, what's your name? You'll say Anmol. What's your date of birth? You'll tell date of birth. What's your blood group? You'll say blood. You'll tell your blood group. There is no operation involved over here, isn't it? Because these are your attributes. These are your properties. So what is the shape of the data frame? Which columns are there in data frame? All these are attributes. But when you ask for head, let's see what this statement does. df.head. You just check this. df.head. I am running this. It is going to print. I'll run it. It's going to print only the first 5 rows. See the difference between giving df, it prints all rows. Just check. And df.head will print first 5 rows. So we can patiently check what are the details in the first 5 rows. You can see 0 to 4 is the index for the row given, or ID is from 1 to 5. Similarly, we have df.tail. df.tail is going to print, if I run this, this is going to print last 5 rows, you can see. Okay, there is one more interesting function called sample, df.sample. What this does, it displays any 5 rows. Randomly, it selects any 5 rows and it displays. Just check. We have to give how many samples you want. For example, if you say sample 5, it will now sample out 5 rows, any 5 rows. Now you see the output. See, it has selected 136th row, then 73rd, then 149th, then 21st, and 142. If I run this again, if I run the same command, it will give some other 5 rows. Or maybe I can select 10 rows. Sample out 10 rows from the entire iris data set. So head displays first 5 rows, tail displays last 5 rows, and sample can be used for displaying any number of rows. You can just give how many rows you want, and it will then randomly select those rows and display. Okay, please try to understand what you're doing. You are trying to understand the data. By doing all this, you are trying to understand the data. Okay, I repeat, by listing the columns, by looking at the shape, by looking at first 5 rows, last 5 rows, some sample, you're trying to know what the data is. And good step in machine learning is spend as much time as possible to understand the data. Relax. Don't make your hands dirty directly by coding. We are not going to achieve anything from that, because the coding is going to be done for the data. Because data is there, we are going to do predictions. So it shouldn't happen that we literally don't know anything about the data and we have started coding. Okay, so what are all the things we have seen till now? As far as Pandas library is concerned, what Pandas offers, it offers pd.read CSV. Read CSV, this function which opens a CSV file, but it opens the file and loads it in data frame. This df is object. This is an object of data frame class. And this data frame class has magnificent functions and attributes. So you can just ask for df.columns. This is an attribute. Or you can ask for df.shape. This is an attribute. Or you can list first few rows using df.head, or last few rows using df.tail, or you can sample out some rows by saying df.sample maybe 10. Please try to understand all these words. All these words are defined in data frame class. And that's why we can call these names on df, because df is an object of data frame. What else can we do with this data frame? Let's see. You just recall when we said df.head, it displayed first 5 rows, but it displayed all the columns. Many times, we are interested in seeing only sepal length, sepal width, and species. Only these 3 columns we want. We don't want to see petal length cm and petal width cm and this ID column. How do you do this? Okay, I hope you understood the problem. We want to show only sepal length, sepal width, and species, but hide these columns. We don't want to see them. So the grammar is, you say df, and now after df you place a square bracket. Take your own time. You take time in such a way that you will never ever forget this, because now in every project that we are going to handle from now onwards, every project, These steps will be same always. We will play with the data and these commands will be written by us. Okay. DF, you put square bracket. What do you want? You want sepal length centimeter, sepal width centimeter, and species. Correct? So you give those names in the square bracket. I want to see sepal length centimeter. I want to see sepal width centimeter. I want to see species separated by comma. But remember, these are column names and column names must be written in quotation always. So I'll give quote. Okay, what's the first name of the column? Sepal width centimeter. Remember, or you can just go up and see. Okay, sepal length centimeter, sepal length centimeter, comma. The second one is quote sepal. This is going to give error, by the way. Sepal width centimeter. Okay. And the last thing I wanted to see is species. Okay, comma, quote, species. This is wrong. This is going to give an error. Okay. But I made clear by giving DF. DF is my data frame. I have given a square bracket. So what are square brackets used for? For list. It's a list of columns I have given. I'm strictly saying DF, show these list of columns. That's it. Square bracket, come on. Square bracket is used for list. And I have given list of columns separated by comma in that square bracket. Okay, let's try to run this. Oh, good Lord. There is a trace back. You see, there is a trace back. It's an exception. And it gives key error. Key error means it has not understood one of these names. Let's see what it says at the end. All these things it has not understood, it says. What is all this? Remember, in Pandas, when you are using data frames and when you are dealing with column names are case sensitive. That means if this S is in capital, this L is in capital, the C is in capital, then you should give the column names in the same way. S is in capital here. Okay, L is in capital, C is in capital. So be careful about this. And similarly, the same goes over here. Width and the C, and even this S is capital for the species. Still it will give an error. Now I have preserved the case. Let's try to run it. Oh, good Lord, it is still giving an error. Now I have written these names absolutely well, correct? Absolutely well. But still it will give the same error, key error, and the same error is listed. So when one very important lesson I am giving all of you. Look, your aim is you are working with data frame. Cool. Wait a minute. You are working with data frame and you want to select something from the data frame. Your aim is you want to select something from the data frame. Then first rule is whenever you want to select something from the data frame, I will go to the empty page again. I want to select something from the data frame, then write the name of the data frame and then put square bracket. Okay. Now this square bracket is meant for telling Python that we are ready for selecting something from the data frame. Now this part here is written as what do you want to select? What do you want to select? You want to select 3 columns. Sepal length centimeter, petal length centimeter, sepal width centimeter and species. 3 columns. Then you make a list here. Please try to understand. And then give sepal length, comma, I'm writing in short, sepal width and species. So this square bracket is compulsory whenever you are trying to select something from data frame, and then what do you want to select is given as additional list. I hope you have understood. Just see, I'll just make that improvement so that we have been getting error for a long time now. And what I will do is I'll put a square bracket inside again over here, and then I'll close the square bracket over here. This is the list of columns I want to show. So 2 square brackets here. Fine. Let's run this. Oh, that's the way. Yeah, sepal length, sepal width, species, and all 150 rows you can see. So many times what happens, your data frame has say 10 columns. So it's very difficult to see all columns in action together. Or many times, you get to know very well that some columns are useless, like name of the customer. What prediction you are going to make from name of the customer or address of the customer? You don't want to see that. So you can give list of columns inside one more additional square bracket inside the data frame. Okay. So maybe you are interested to see only species, let's say only this column species. So how will you write that? df square bracket. Remember, you are selecting something from df, so that square bracket, and then again square bracket, and then what do you want to list? List of columns is only species. That goes in additional square bracket over here. If you run this, you will get only species, all 150 rows. I hope you are understanding. So going back to our work that we are doing on pandas, we saw how to sample out the rows. Now we have also seen how to sample out the columns. You can just give df square bracket, and inside the square bracket, you can give list of columns. List of columns. I hope these things are very, very clear. At this moment, maybe, you may not understand the importance of this. That why are we watching these columns? What are we going to do by that? But suddenly when I will open up a new problem to you, I will open up a new problem without telling what that problem is. Like how I took you to iris flower Wikipedia. I told what is sepal length, what is sepal width. I've shown that page. I've described it. But if I suddenly give you at 12 o'clock midnight, I give you a CSV file and don't give any help. This is the CSV file. अब तू CSV फाइल ओपन कर, देख उसमें क्या डेटा है, तू समझ और फिर तू ही प्रोग्राम लिख. ऐसा अगर होगा तो फंस गए ना. हमको ये करना ही पड़ेगा. We will have to roam around the data, understand the data, what each column, what kind of values each column has, and so on. Okay. Now, let's put up a question. Let's say I want to list only that rows where sepal length, I'm writing in short, sepal length is greater than maybe greater than 1.5. Okay, that is sepal length centimeter. This I have written in short, sepal length centimeter. Wherever it is greater than 1.5, only those rows should be shown. Is my requirement. Just check this. If I list a df, okay, df dot sample 20, maybe 20 rows I am sampling out, then you can see sepal length centimeter. I'll revise this problem. Almost all sepal length centimeters are greater than 1.5. So what I will revise here is maybe greater than 6.5. Okay. So you can see some sepal lengths are greater than 6.5, but some are lower than 6.5. So these rows must not be shown. Only those rows must be shown where sepal length centimeter is greater than 6.5 is our requirement. Okay. So how do you deal with this problem? Look how consistent our method is. Tell me, aren't we selecting something from data frame? Correct. So what will we do after df? We will give square bracket. Yes, correct. Okay, now what do you want to select? You want to select those rows where sepal length centimeter is greater than 6.5. Isn't it so? Then what would you do? Number of things we might try. Like we might say in this quote, we will say sepal length centimeter in quote we have given is greater than 6.5, and we think that okay, we have given this square bracket, because we are selecting something from df, and then what is our condition? We have given sepal length centimeter is greater than 6.5. This is rubbish, absolutely rubbish, because what it will check is this word. Now it is just a word for Python. Is this word greater than 6.5? It is like asking, is Samir greater than 6.5? This is so silly. I mean, some way you have to tell that sepal length is a column of df. Some way you have to tell. Then the way is that you give df again over here, df square bracket, and then square bracket close here. I'll write it on an empty slate. Just have a look at this. Get used to this. df, I'm selecting something from df. So no doubts, the square bracket is needed. What do I want to select? Wherever sepal length centimeter is greater than 6.5. So surely I am checking something from sepal length. But sepal length belongs to df. So I will write df square bracket sepal length. You tell me what this is about. What this is about. df square bracket sl. This is like selecting only this column sl and then comparing it with 6.5. And then comparing it with 6.5. So df square bracket sl is going to return me this column. Okay. And then this values, we are comparing it with 6.5. Okay. You didn't like it. Okay. Let's see. df square bracket. Why this square bracket? Because we are selecting something from df. But what's the condition? SL should be greater than 6.5. So write SL, no quote now, no quote, but SL belongs to DF. So DF dot SL greater than 6.5, much better. So select something from data frame such that sepal length of data frame is greater than 6.5. Any method that suits you, you can use. I basically use this first method, but many of them use this dot notation because there is no need of giving square bracket and then the quotation. Okay. Now, those who have learned DBMS, I am not saying that you should know SQL, structured query language, that I will tell you what is structured query language. But this statement that we have written is nothing but structured query language statement as select df dot select star from df where this condition df dot sl is greater than 6.5. Just don't worry about this. I was just relating it, but this is the way how you can query. Please try to understand this was a question we were asking. Till now, we have not asked any question to our data. Now we are asking questions that how many rows, which rows you have where sepal length is greater than 6.5. I hope you are understanding. So what's the grammar? Let's go to untitled. Check. I am revising this. Oh, I have already done that. If I run this, sorry, if I run this, I'll get only those rows checked where sepal length is greater than 6.5. Or if you don't like this notation, okay, you can remove this. You can remove this quote also, but put dot here. df dot sepal length centimeter greater than 6.5. Even this will work. Whichever method suits you, you can use. But this is going to show only those rows where sepal length is greater than 6.5. Okay. So let's try to solve a problem. List only the rows where sepal length is greater than 6.5 and sepal width is, let me check the output of this so that we can get some help. Sepal width is greater than 3. Let's see. Sepal width is greater than 3. Now we have a complex condition. We have 2 columns to check, and those rows which pass these 2 conditions for that row will be filtered out. Correct? How would you write this? Let's go to empty page. We are selecting something from DF. So it's square bracket. But on what basis are we selecting? First of all, sepal length should be greater than 6.5. But sepal length belongs to DF. So first notation is DF square bracket sepal length in quote. But this is not the only condition. Other condition is sepal width should be greater than, I think, 3. But sepal width is a column in DF. So DF square bracket sepal width. Now there are 2 conditions written over here, and we want both of them to be true, only then the row should be selected. So we use one operator called AND over here. Okay. This AND operator will make this entire condition true only if both are true. This is like logical AND. But there are some strange rules of AND that both conditions must be given in individual bracket. If you don't give this bracket, you will get an error. And AND should be outside the bracket, but inside the square bracket. Strange. Or other grammar is, you are selecting something from DF. So square bracket. What do you want? SL should be greater than 6.5, but SL is a column in DF. So DF dot SL. Nice. This is another way of writing the same thing. And DF dot SW greater than 3. But these individual conditions should be put in the bracket and should be outside the bracket. This way, you can combine multiple conditions and select something from the data frame. Okay. So let's see. We'll give DF square bracket. And the first thing is DF dot sepal length centimeter, correct, is greater than 6.5, and DF dot sepal width centimeter is greater than 3. Okay. And this square bracket was already written because we are selecting something. We are selecting something from DF. So if I run this, it's going to show an error. And we really don't understand. Oh, there is sepal width. There is a spelling mistake I did. Okay. See the error shown is no attribute sepal width CM. So sepal width has been misspelled. Okay. Let's try. It's still giving an error, type error. You can see that it gives some strange thing like it's array or scalar. You have to use Boolean operator. Boolean condition should be given. That's all because you have to give additional bracket for each condition. So first condition is DF dot sepal length should be greater than 6.5, and the second is DF dot sepal width centimeter should be greater than 3. Let's try to run this now. Yes. Just check only those rows where both conditions are true. This is greater than 6.5. This is greater than 3. Only those rows will be shown. Okay. This is the way how you can collectively check for multiple conditions while filtering something from the data frame. I hope that's understood very well. Okay. Now, let's do some more fun. Okay. See, these names of the columns, let me remind, these are the names of the columns, are so big that when we are working on this, it's really a punishment that we have to type such big columns every time. Yeah. Can we rename these columns? Like, let's keep ID as ID. That's very short and sweet. But this can be SL, this can be SW, this can be PL, and this can be PW. And let's keep this as species. Let's not change this. Can we do that? I hope you understood. What we are up to is renaming the columns. Just for fun, so that we don't have to type that big names again and again. Okay. So what do we do? What I was saying is, how do we rename these columns? What we can do is, let's make C is equal to, just check what I am making. I have given square bracket. Immediately you should say, sir, you are making a list. And you have given the name as C. Okay. What I will do is, I'll say, okay, this is ID. Then next is SL. All small I have written. Even this I can write in small only, instead of capital and small. ID, SL, SW. Okay. Then PL. Then it will be PW, and last one is species. Let's keep that S also in small. So this is a simple list of strings. It contains 5 strings, isn't it? And now, if I give df dot columns is equal to C. You recall what did df dot columns do? It told us which columns are there. Look at this output. df.columns. It said that these are the columns, but now I am saying df.column should become equal to C. Okay, let's try to first run this. Okay, it got executed. Now what if I print df? Oh, look at the column names. That means I have changed the attribute columns. Columns is an attribute, I told you. It's a property, and I've changed the property. I said that columns, now you B equal to C. So all these names will be given sequentially to all the columns. That's the way how you can change the names of the columns very, very fast. But now you don't have to work with small and capital letters and such big names. So going to the work that we are doing is that we now know how to take out something from df, and we also know how to rename the columns. Rename the columns. Fine. Okay. Now the next thing is this ID column, you know, everybody will agree is not at all important to us, because all the predictions will be done using these 4 columns. This is just a row number given. You'll say, sir, let it be there. Why you are talking about that? No, our Python program will, what do you say, will stupidly use this as data and will do predictions using this data. We don't want any data which is not going to be used for doing any kind of prediction. We just want to throw it out. I hope you're understanding what I'm saying, that when I list df, you see, this is the data important to us. From here, we are going to tell which type of flower it is. What are we going to do with this row number? We are not going to be helped by this row number. We can simply throw away this column. So the next point is, how do you drop a column such as ID column you don't want? How do you drop? Then df has got a function called drop. Remember, df is the data frame. This is the function. Just tell which column you want to drop. The column you want to drop is ID. Give the name of the column in quotation. Column name hai, to quotation mein aayega. Okay, let's try to run this. Drop ID. It will give an error. I think so. It has given key error. You know that key error comes only when you have misspelled some column name. No, but column name is correct, ID. Why is it giving error? Let's try. Let's find out some more reasons. It says ID not found in axis. Oh, good Lord. Now, what is this axis? You see, drop is meant for both dropping rows or dropping column. Take your own time. Take your own time. You know, df is like a matrix, isn't it? df is like a matrix. Maybe you want to drop a particular row, then you use drop. Maybe you want to drop a particular column, you still use drop. Okay. Now, what you have said is drop ID. Now, this data frame has not been made so intelligent to know whether you want to drop. What do you want to drop? You should tell that ID is a column and entire column has to be dropped. How do you say entire column has to be dropped? There is one more parameter called axis, and you say axis is 1. When you say axis is 1, it means that the entire column has to be dropped. Actually, 1 means row. Please have patience. 1 here, axis is equal to 1. 1 means rows. I repeat, axis is equal to 1 is written. 1 there means rows. Okay. Now, what we are telling is, I want to drop ID. I made it very clear. I want to drop ID. I want to drop this ID, and axis is 1 is given. That means in each row, whatever is ID, I want to drop. In each row, axis equal to 1 is given. So this should be working for all rows, I am saying, by giving axis is equal to 1. I hope you're understanding. Sometimes the things doesn't become so clean. I mean, till now, you know, we had some relaxed feeling. I mean, okay, we are understanding these grammars. Don't worry. Pandas gives other syntax also. If you don't like this, I will give you another syntax, but axis is equal to 1. Okay, let's try to run this. And after dropping, let's print df also. Okay, let's see. Oh, still there. You see, It's still there. What's going on? Actually, I have dropped ID. Axis is 1. I've dropped everywhere, wherever ID was there in all these rows I have dropped, and then I have printed DF, but it's still showing ID. Now, these changes done, of dropping a column are temporary. They are only for that line. They are only for that line. And as soon as that line ends, what it does, it restores the previous data frame. You will say, then sir, what's the use? अभी drop किया, अभी retain भी कर दिया. ऐसा तो क्या फायदा है? But then you can tell pandas that this change should be permanent by writing in place equal to true. Check that true is a Boolean value. In place equal to true means these changes should occur in DF permanently. Whatever you are dropping should be transferred to DF. So if you are dropping this, oh, that should be the new value of this row without this value. If you are dropping this 2, this should be the new values in the new DF. Now if I print DF, you can see that ID is dropped. And the point is now ID is permanently dropped because in place equal to true has been given. Okay, that's the way how you drop a column. And secondly, if you didn't like this, axis is equal to 1. Really, if you didn't like it, I don't know, there's no such reason that you don't like it. But in case you didn't like it, then just better don't give it. Okay, but then make it clear that you want to drop columns. Check the word columns is equal to, and then give square bracket, and then in square bracket give the column that you want to drop. अब तो आपने क्लियरली बोला है कि मुझको पूरा कॉलम ड्रॉप करना है, लेकिन वर्ड देखो कॉलम्स. That means you can give any number of columns that you want to drop here. Maybe you want to drop ID and PL both. Oh, it will be very dangerous to drop petal length. I'm not dropping it, but now both columns will be dropped. Okay. Now axis need not be given because you have made it clear that you are working on column and entire column should be dropped. This is alternate grammar, but then still this in place equal to true should be given. Otherwise, the changes will be temporary. Okay. This is the another way. Now if I run it, there will be an error, and I will give you 30 seconds to think about why this error is caused. Okay, there is no mistake in the grammar of this sentence. Grammatically it is correct, but it will give trace back key error. It will give key error, and it will say ID not found in access. Again, ID not found. Just check. This code of dropping column equal to ID has given an error, and the turn is yours. I'm waiting just for few seconds. Maybe I'll wait for 30 seconds. Give me your suggestion, unmute yourselves and tell me what error it might be. Due to what might be this error? Any idea? Any suggestion? That there is no mistake with the grammar. Grammar is perfect. Grammatically, it is not wrong. That's why it is giving trace back. You just check. It is giving trace back. It is an exception. See, the mistake here is we are asking pandas to drop column called ID, but ID column was already dropped. I told you that ID is now permanently dropped, and you are asking it to drop ID. It says ID not found. I hope you have understood. This happens many times in Jupyter Notebook. What happens is that you run some code, you delete something that is lost now, and you try to use it again. अरे जो delete किया है वो फिर से कैसे delete हो सकता है? वो बोलता है अभी ID not found, है ही नहीं डेटा फ्रेम में. ये डेटा फ्रेम लास्ट टाइम हमने प्रिंट करके देखा था, उसमें ID नहीं था. परमानेंटली वी हैव डिलीटेड ID. अब आप कैसे बोल सकते हो ड्रॉप ID? वो मिस्टेक है, इसीलिए वो बोल रहा है की एरर. और बिलीव मी, दिस डजंट मेक सेंस टू बिगिनर्स. आई मीन वो सोचते रहते अरे ये क्या मिस्टेक है, समझ में ही नहीं आ रहा है. Ah, yes, it was already dropped. That's why it's saying that I can't drop ID now. It was already dropped. I hope you have understood. Okay, very interesting. So what you can do in such situations, if you really want to run this, or if you really want to run this, what you can do, you can again open iris.csv. अब मुझे बताओ, ये फिर से मैंने रन किया तो वो ओरिजिनल डीएफ मिलेगा ना? हाँ, ओरिजिनल डीएफ. चेक दिस कॉलम्स. आई विल रन दिस कोड अगेन. देखो ये कॉलम नेम्स है, हमने उसको रीनेम किया था. We got that earlier column names. Shape obviously will be 150 by 6 and 10 samples. Let's check. These are the 10 samples, correct? And head, and this will give me only sepal length, sepal width, species, and so on, correct? And this was what we had used for renaming the columns. So if I run this code, I have renamed all the columns. Okay, let's try printing df.columns. This will print new value, new names of the columns. Now I have ID column. Now let's try to run this. I hope you are understanding. If I run this, check that ID is dropped. And what was the first grammar I explained? Don't use this keyword columns. Just give ID. I want to drop this, but now make it clear by giving access is equal to 1. You know it's going to give an error now. Again, we are asking it to drop ID, but ID was already dropped. It's going to give an error. Yeah, let it be, let it be. It's good news that ID is dropped. Finally, what we ultimately want is we wanted to drop ID and ID has been dropped. Okay. So I hope you now know how to drop a column. No issues till now, I hope so. Now, once we have seen how to drop columns, let's see, let's do some more interesting stuff with this. You know, if I write df square bracket, again square bracket, and suppose I say SL. Now these are the renamed columns, you remember. So SL. So you know it's going to show me only SL. And this is how you select some column, or maybe multiple columns. You could have given comma. What if I assign this to something? Suppose I say X is equal to, let's say X is equal to this. Okay. And I print X. I print X. Let's see. It's the same output. Good. It's the same output. So basically, you can select some column or list of columns and put it in a new variable. Then that new variable will contain only those columns. Isn't it? Let's see. Let's say type of X. What we will try to print type of X. Which type of variable is X? Oh, that's also data frame. That means you are creating a new data frame from an existing data frame. Just say that X will be equal to only SL column from your DF data frame, isn't it? So now X will always contain only that SL column. You can do like this. Yes, I hope you got this. Now I have a problem for all of you. I have a very interesting problem for all of you. Create a new data frame from DF. So DF is our original data frame. Create a new data frame from DF named capital X. This should be the name of the new data frame. Capital X, which contains sepal length, sepal width, petal length, petal width. That's it. No species. Species should not be there in X. And the another problem is, I'll just copy this. Create one more new data frame from DF and name it as small y. Name it as small y, which contains species. which contains species. So df should remain same. Original data frame हमको वैसे ही रखना है, but x should contain 4 columns and y should contain the last column. Okay. Quickest way of doing this is what you can say is capital X is equal to df square bracket, and then again square bracket. What do you want? Sepal length, comma, sepal width, comma, correct, petal length, comma, petal width. Oh, you know now that this X is going to contain only these 4 columns from df, correct? And what if you say y is equal to df square bracket species? You know now that y is going to contain only species. Okay, what if you print x? Let's see. First of all, by printing x, it's going to contain only these columns. And what if you print y? Y is going to contain only species. That's the way how you can separate out a few columns in one df, one data frame, and other columns in other data frame. You can always separate out them. You will see all these steps in our real project. When we actually develop a project, you will see this, that whenever some CSV file is given, we often have to separate out X and Y. And Y always contains the last output column. This is one of the favorite steps in any machine learning algorithm. Anything you want to add? I mean, I'll just wait for some time. There is absolutely no reason about efficiency or anything like that. Absolutely no reason. But you know, machine learning algorithms developed by Python over the years, you know, they made their own dedicated classes. And for every machine learning model, they said that the data should be in this form. It should be in data frame form. Only then we can learn it. So if you want to write your machine learning algorithms or programs in 2 lines, because Python has already given the ready-made code, then they say that the data should be in this form. That's the only reason that you make data frame, and then you pass the data frame to a ready-made algorithm which Python has created. Otherwise, efficiency wise, to open this data, to read the data, absolutely not. Python has same efficiency as any other DBMS. You can say this is a monopoly of Python. You can say, where Python says you want to use my libraries, then you create data frame, because I have done all the programming using data frame. So maybe you want to predict whether the patient has cancer or not, then there is already a function called KNN, K nearest neighbor, but K nearest neighbor needs data frame. That's right. So not only data frame, sometimes arrays also can be passed. Okay, but arrays and data frames are the 2 favorite types of data representations in Python libraries that we use. Okay, yeah, okay. Because tomorrow, you know, when we come back at 11 o'clock, tomorrow we are having a session. We are going to have a quiz. I'll be opening a new data for you, and absolutely I will not give any idea about that data. And then what we can grasp from that data, we have to see. Okay, so I'll continue for some more time today. I will now work with the original data frame. Remember this DF, we still have this data frame. We have a problem now. We want to know how many types of values are there under species column. Check my words. How many types of values are there under species column? By the way, we know the answer. There are 3 types of values. One type of value is iris dash setosa. Other is iris dash virginica. And third type of value is iris dash versicolor. Correct? But we want to know that which type of values are there. So what you do is, you first of all, you know, select the species column. All are comfortable with this species column. So df square bracket species, correct? And then dot values you give. Now values is a function. Check that values is a function. Let me check whether this is running. No, it gives type error. Wait a minute. We need to qualify this properly by writing df square bracket species and then dot values. Oh, it still gives an error. What's the error? Let me check. Or let's check for minimum df dot values. Okay. No. What's the problem? Wait a minute. df square bracket, and if I give only species and then square bracket close dot values. Let's take the help of Google. Many times I forget the grammar. Please excuse me for that. So values function in pandas. Okay. Here we go to the first suggestion given. What does this say? Data frame dot values attribute returns numpy representation. Any example here? They have made a data frame, and the data frame has weight, name, and age of various people, and df dot values. So there is no bracket after that, and then they are printing the result. Oh, so this is going to give this is going to give just the array. It's going to return an array. Oh yes, the function which I am talking about, I'm so sorry, the function which I am talking about is value count. I think so. Value count function. Okay, this function. Yeah. So sorry, just excuse me, because this might happen every now and then, because you know it's human to forget the function names. Function names cannot be remembered. All function names cannot be remembered. So this happens many times. So you just see, just have to give the name of the data frame and then value counts. So it will tell which type of values are there in each of that particular column. Okay. So in our case, we can give df dot value counts. Let's go back here, and the function name I was writing was wrong. It is df dot value underscore counts. Let's try with this. See, we will be seeing this iris, setosa, and all that. But what it is saying is that sepal length 4.9, sepal width 3.1, petal length 1.5, 0.1 is petal width, and species setosa. This row occurs 3 times. Exactly this row, you know, occurs 3 times. Or these values, you see, these values occur exactly 2 times in your data. And then many more rows are there. So it has not shown all the rows. Okay, let's try something else. If it works, df square bracket, and then let's give species dot value counts. Let's try this. Now I have not given df dot value counts. I have given df species dot value counts. Please try to understand what we are trying to figure out is that under the species column, how many iris versicolor are there? 50. Iris setosa 50. Iris virginica 50. What's the importance of this function? You know, what's the importance of this function? Just imagine that I am having some arbitrary data frame like this. Just check. Say temperature. First column is temperature, and temperature might be cool, hot. Okay, then again hot, cool, and so on. So under temperature column, there are 2 types of values: cool or hot. That's it. Okay, and then windy column, a strong wind or mild, then again mild, strong, This is our data. This is our data. So under windy also, you only have two types of values, strong and mild. And then we have some more column, let's say as humidity. And humidity is low or moderate or very high. Then high again, and then moderate. So there are only three types of values under humidity column. As a data analysis, what you might want to know, is that how many types of values are there in temperature. You'd say, sir, so what? You read the data, but what if there are 50,000 rows? Are you going to go through 50,000 rows and trying to figure out which type of values are there? You just say df square bracket temperature, name of the column, dot value counts. That's it. Now it will say cool maybe occurs. This word under temperature occurs 50 times. So there is a type of value called cool. Hot occurs say 60 times. And then it doesn't show anything. That means these are the only two values occurring under temperature column. Similarly, if you say df square bracket and windy dot value underscore counts, then it may show strong. This word occurs say 40 times, and mild, this word occurs say 70 times. Then only these two words are there because it has not shown any other category. This is the way how you can find out which values are there and for how many times they occur under that column using value counts. Very, very, very interesting and important function which you can use. So it's ridiculous, to give SL ka value counts. SL is a real number. Come on, it's a real number. What will you do by counting how many times 1.5 occurs, how many times 1.8 occurs, how many times 2.1 occurs? है ना? SL तो real number है ना? Usually value counts is used with labels. जैसे मैंने बोला cool, hot, ऐसे अगर labels होंगे column के नीचे और हमको check करना है कितने type के labels है, we can use value counts. Giving just the name of that column, giving just the name of that column, and we can say count how many types of various values are there. And we know that there are 50 versicolor flowers, 50 setosa flowers, and 50 virginica flowers. Okay. So I think we should stop now. See you everyone. Bye. Good night. Good night, all of you.